Okay, people, we reunite, and we're going to finish up 6.2. 6.2 is sort of an introduction to polynomials. We took care of definitions, and we took care of the degree of a monomial and the degree of a polynomial. So we're going to move to this next little introductory part, which is not necessarily that new. We have already evaluated functions. We just didn't call them polynomial functions at that time, but we've actually evaluated these kinds of functions. This equation that we're looking at on number 1 is a polynomial function because we see the function notation right here. And it's a polynomial function because this is defined in terms of a trinomial. X squared minus 5x plus 6 is a trinomial expression, so it's a polynomial. We call this function a polynomial function. And we evaluate it in the same way as we've evaluated all functions. So let me just use the right terminology and read this, and we'll go through it and do it because we've done it before. Here's how it reads. If the value of function f when the domain is x is equal to the range of x squared minus 5x plus 6, they want us to find the value of function f when the domain is -2. So we're going to take this domain value of -2 and we're going to substitute it wherever we see the domain letter of x. Old news now. Bring down the equal. Right in here first. We'll write down the value of function f when the domain is -2 will be equal to, now we're going to substitute. -2 goes in place of x, you're going to need a house. Put that exponent on the outside. Bring down that coefficient of -5, make another house. In place of x, that domain of -2. And then bring down the constant term +6. Now we'll do the mathematics. -2 to the second, -2 times -2, +4. We can take care of this part right now. This is a -5 multiplied by a -2. A +10, bring down the +6. We're ready for the final summation statement. The value of function f when the domain is -2 is going to give us a range value of the sum of those three, which would be 14 plus 6, 20. Circle it. Number 1 is done. Number 2, if the value of function g when the domain is x is equal to this polynomial range, is equal to 2x cubed minus x squared plus 4x minus 1. Find the value of function g when the domain is -3. So we begin. The value of function g when the domain is -3 will be equal to, now a little bit more time to give to substituting this right. Bring down that coefficient of 2. See, there's a time sign right here. So we're going to use a parenthesis. And in place of x, that domain of -3, put the cubed exponent up there. Bring down the subtraction sign. Make a house. In place of x, put -3 to the second. Bring down the +4, make a house. In place of the x, -3, and then -1. Don't go multiplying 2 times negative 3. That's out of the order of operations. Bring down the 2. You make a house. Because you see, people, this 2 is eventually going to have to be multiplied with the answer that we're going to get when we take negative 3 to the third. Negative 3 to the third. If you needed to do something like this, negative 3 times negative 3 times negative 3. There are an odd number of negative factors. That means negative. 3 times 3 is 9, and 9 times 3, negative 27. Just going to bring down this subtraction sign. Now let's take care of this. Negative 3 to the second. Negative 3 times negative 3, 9. I'm just going to go ahead and bring that down. I'm not going to touch it at all yet. Back to the left. We'll multiply here. Positive times negative. Negative 54. Just bring down this negative 9. That's really what it is. Multiply this positive times that negative. That's a negative 12. And the little caboose is negative 1. Bring down the value of g when the domain is negative 3 is going to give us a range. Well, people, this is a debt. This is a debt. A third debt. A fourth debt. They're all negative. Add their absolute values together and take the common sign. So we'll bring down that common negative sign. 54 added to 9, 63. 63 added to 12, 75, 76. The range is 76. Done. That's evaluating a polynomial function. We have done it before. We just never defined it as being that, but we've done it before. All right, now the final two things that we're going to take care of in 6-2, we're going to now come to the first two operations of polynomials. Addition of polynomials. We'll do it first, and then we'll deal with subtraction, and then we'll call it quits for today because 6-2 will be done. Rule. When we are adding polynomials together, you simply combine like terms. You don't do anything with exponents. You simply combine like terms. And when we combine like terms, we add coefficients only. So on number 1, I didn't have room to write the whole thing out horizontally. I had to give myself some space. So here is polynomial number 1, and we're going to add it to polynomial number 2. And we're going to simply do this. We're going to start with the very first term in this first polynomial, which is negative 7x to the third. Its variable part is x to the third. I'm going to underline it once. We go to the second polynomial, and we also see a like term that has the same last name of x to the third. We're going to underline it once as well. And we're going to add these two like terms together. And when we add them together, we add the coefficients only. You don't do anything with the x cubes, they'll just come down. We add the negative 7 with the positive 17. That's really subtract, and that'll give us 10x to the third. Go to the second term of this first polynomial. It's an x squared. I'll consider underlining it twice. In the second polynomial, there's another x squared. I'll underline it twice. We'll add those like terms together. Positive 6, positive 2, positive 8x squared. That's done. We go to the last name of x. They're like terms. Maybe 3. Maybe you don't need to do anything. A negative 10 added with a negative 4. A negative 14x, and then take care of the constant terms. A positive 17 coupled with a negative 13, a positive 4. There's our sum. Now, by the way, just to insert some vocabulary here. Here's our polynomial. That's the classification of it. The degree. Well, the degree of this first term is 3. The degree of the second term is 2. The degree of the third term is 1. He has no degree. The greatest degree, 3. 3 would be the degree of that answer. One more. 10x to the fourth y squared minus 3x squared y squared plus 2xy plus this one. Let's start with him. Very careful now. Let's start with him. I'll underline him once. What am I looking for? I'm looking at my variable parts. That's an x to the fourth y squared. I look in the other trinomial. There is another x to the fourth y squared. I'm going to combine positive 10 added with a negative 16. Negative 6 x to the fourth y to the second. Don't do anything with the exponents. They stay the same. Just add the coefficients correctly. Well, they're done. Let's go to this one very carefully. This is negative 3x squared y squared. When you look in the other polynomial, there is no x squared y squared term. Therefore, take this one right here and just bring it down right beside the portion of our answer. You can't add them with anything because you don't have any like terms in this one. So just bring down the negative 3 x squared y squared. That one is done. You can either go to him, or if you want to come down to this second polynomial and realizing that this variable part is x squared y, and we don't have any x squared y up there in the first, we can bring this one down as is. But these last two, they're like. That's a positive 2, that's a negative 1. Positive 2, negative 1, a positive 1. You can show the positive 1, or you can just write down plus xy, and it satisfies the situation. Now that's addition. When we are adding, we combine like terms. Now this subtraction, here's the rule. When we are subtracting polynomials, just look at this first situation right here. There's the first one minus the second. When we subtract polynomials, we basically follow the same rule that we do when we're subtracting real numbers. The rule of subtraction says we leave the first polynomial as is. You don't alter the first one at all. You go to the subtraction sign, and the rule of subtraction says you change it ordinarily to an addition. I'm not going to do it because I'm going to offer an alternative which is the same thing, but I'm just kind of talking about the rule. The first one stays as is. The minus sign goes to a plus, and then each and every term of the second polynomial goes through a sign change. You would change that sign, that sign, that sign, and that sign. That's the rule of subtraction. We're going to accomplish the same thing, but with maybe a little bit less work. Rule: to subtract polynomials, we're going to distribute the second polynomial, we're going to distribute the second polynomial by a negative 1. And then we're going to combine like terms. We're going to insert right after this subtraction sign a 1. Our distributor is negative 1. When we distribute to each and every one of those 4 terms in the second polynomial, the result is going to be the same as if we use the rule of subtraction. He'll become a negative, he'll become a positive, he'll become a positive, and he'll become a negative. Let's do this. Bring down every term of the first one. Just bring it right out of the house. 18x cubed minus 2x squared, negative 7x, positive 8. Nothing changes in the first one. The second one, we distribute each term of the second polynomial by a negative 1. Negative times positive, negative 9x cubed. Negative times negative, a positive 6x squared. Negative times negative, a positive 5x, and negative times positive, a negative 7. And now we combine like terms. There's an x cubed. There's another one. Add coefficients only. A positive 18 added with a negative 9. That'll give us 9x cubed. Let's go to the x squared. There's another x squared there. Let me just kind of underline them twice and underline them twice there. Add coefficients only. Negative 2 added with a positive 6. A positive 8. A negative 2 added with a positive 6. A positive 4x squared. Sorry. Go to the x's. Sometimes I'll circle. Got a negative 7x and a positive 5x. Really subtract a negative 2x and then the caboose. Positive 8, negative 7, positive 1. There would be our difference. There would be the answer. Now folks, problems 2 and 3, I'm going to pull away from here. I've got them over on the whiteboard. Wanted to have a little bit more room. Here's the key. Number 2 and number 3 is not ready for us to subtract yet. It has to be translated first. You see, it's not written like the first one that we did that was already ready. This one is not ready. It has some words in it, and we're going to have to translate the statement first. It says subtract this trinomial from this trinomial. Subtract from. Subtract from means when you translate, you have to reverse the order. Subtract from is like less than. Subtract from means whatever polynomial comes after the word from, this trinomial right here, it must be written first. He's first. He's second. So, subtract from. Whatever comes after from is translated first. So we're going to write this and we're going to put it in a house. He's going to come first. 13a squared b to the fourth. Negative 17ab squared positive 7ab. Close it off. He came first. Then your minus sign. And then your second house. And what goes in the second? The guy that came first here. Negative 5a squared b to the fourth. negative 8ab squared, negative ab. Now the problem is set up. I'm just going to remind you again. Whatever comes after from is written first. We wrote it first. Here's the first one. It's going to stay just as it is right here. I'm going to insert a distributor of negative 1. Down. 13a squared b to the fourth. Negative 17ab squared plus 7ab. Now we're going to distribute the second one by negative 1. There, there, and there. Negative times negative. A positive 5a squared b to the fourth. Negative 1 times negative 8. A positive 8a b squared. And negative times negative. A positive, if you want to show the 1, it's not a bad idea. Show the coefficient of 1. And now let's come back and combine like terms. There's an a squared b to the fourth, and there's 1. I'll kind of underline it once and underline it once. Let's combine and add coefficients. Positive 13, positive 5, 18a squared b to the fourth. That takes care of them. Let's go to the ab squareds. Maybe a couple of lines. There's another ab squared. Negative 17 added to a positive 8. Negative 9ab squared. AB, AB, positive 7, positive 1, positive 8, AB, done. By the way, not to lose this one because it's a good one, if we were to classify this polynomial, if we were to classify it a trinomial, if we were to identify the degree of that trinomial, you first of all identified the degree of each term first, then you pick the greatest value. 2 plus 4. The degree of this first term is 6. 1 plus 2. The degree of this second term is 3. 1 plus 1. The degree of the third term is 2. He wins. The degree is 6. The degree is 6. The degree is not 4. The degree is 6. Number 3, another one. Subtract this poly from this one. Whatever comes after from, first. He's first. The quantity of x to the third plus 2x squared y minus y cubed. Close it off. Then the minus sign. Make another house. You can insert the negative 1 right now. The one that was written first right up here is going second. Negative 6x cubed plus x squared y minus xy squared plus 3y cubed. Down. No changes. It's the first one. Down. X to the third plus 2x squared y negative 1y cubed. Distribute. Negative times negative. Positive 6x cubed. Negative times positive. I'm going to show the coefficient. Negative times positive, a negative 1x squared y. Negative times negative, I'm going to show the coefficient. Positive 1 xy squared, and negative times positive, a negative 3y cubed. Maybe back over here before we combine so there's no messing up. Feel free to put a coefficient of 1 there, and feel free to put a coefficient of negative 1 there. Let's start with the x cubes. Let me go back to the black pen. There's an x cubed. There's another one. 1 added to 6. 7x cubed. They're done. Let's just go right in order. There's an x squared y. There's another x squared y. They're friends. Positive 2 coupled with a negative 1. A positive 1 x squared y. If you want to show the 1, you show it. It takes care of those. Then you'll notice that you've got a y cubed here with a y cubed there that are going to have to be combined. And you can do that right now if you want to. There's no rule that says that you can't. If you want to take care of him next, you can bring him in. Because he's an xy squared, and we don't have any xy squareds over here. So I'm going to bring him in. Positive 1 xy squared. That'll take care of him. And now we'll do the y cubes. You got a negative 1 and a negative 3 down there at the end. A negative 4y cubed. And there is the polynomial answer. There's the answer to the subtraction. Now people, that takes care of 6-2. There will be a homework assignment that will accompany it. And it will deal with all of the things that we spoke about in 6-2. You take care of yourself this weekend as it comes on, and we'll talk soon. Bye-bye.